Okay, Ji, can you hear me?
Yes, sir.
Yes, sir.
Okay, let's wait for 2 minutes so that the rest of the people they can also join. Okay, so we started with the approximate method, and as you can see in the approximate method, what we consider that the current which is flowing in R1 and the current which is flowing in R2 is basically equal, and this means that the resistance which is being offered by the emitter in the circuit is actually very high, and once it is very high, so what is the condition that we say that, let's suppose if we say I1 is equal to I2, so this means that the resistance which is being offered by the emitter, which is basically, if you see the base current which is flowing over here. Okay, as we know this equation, that is IE, as you can see, IE is basically beta times IB, right? And over here, if you see, the base current is flowing through the base emitter junction. It goes over here and then this goes over here, right? So when we are looking from this side, this means it is basically the base current and I1 and I2, right? But the base current is basically when it is being reflected on the emitter side, it is basically beta times the base current, right? Are you getting my point?
No, sir.
If you
No,
see,
sir. Repeat again.
if you see over here, we have the equation IE is equal to beta plus 1 times IB, right?
Yes, sir.
Right? So this means the current which is flowing over here in the emitter is basically IE, right? The current
Yes,
flowing
sir.
over here is IE, but the comparison which is being made over here, I1, I2, and it is IB, right? So the resistance which is going to be seen by the base will be enhanced by beta plus 1 times. Are you getting this point?
Yes, sir.
What I mean to say, because over here we are comparing I1, I2, and IB, right? The IB is actually moving into from the circuit. If you see, it is moving towards the emitter, right? And once it is moving towards the emitter, the relationship between the emitter current and the base current is correlated with beta plus 1 times, right?
Yes, sir.
Now the resistance which is going to be seen by the base current will be enhanced by beta plus 1 times.
ये enhanced का क्या मतलब?
सर
Enhanced का
इसका
ये,
समझ नहीं आ रहा है।
okay, just listen. Because if you see, the current flowing in the emitter resistance RE is IE, right?
यस सर।
Yes, sir.
Is this point clear?
Yes, sir.
But
Yes, sir.
the junction, which is the node over here, if you see, the node over here is this one, right? It is the node on which we are talking about I1, I2, and IB, right? And what we say that I1 is equal to IB plus I2. But what we say, IB is very, very small as compared to I1 and I2, and therefore what we said that I1 is equal to approximately equal to I2. But why IB is being neglected over here? If you see, if we are supposed to take the resistance which is being offered to IE is RE, but if the current over here in this is flowing is IB, so what is going to be the resistance?
Resistance very high, sir.
What is going to be the value of that resistance? If in the emitter
सर
lag,
आरबी
Sir,
नहीं होगा सर.
just listen to me. Just listen to the question which I am asking you. If I say the current which is flowing in the emitter resistance is IE, right? So the resistance which is being offered by this resistance is RE, right? So what we can say, let's see. If you see over here, we have this, and the drop across this will be taken as VE, right? Are you getting this point?
Yes, sir,
VE,
directly
Yes
connect.
sir.
VE should be equal to IE RE, right? Is this point clear?
yes, sir.
Now VE is actually equal to, if I replace IE with its equivalent value, what is it? Its equivalent value is beta plus 1 times IB, right? Are you with me?
Yes, sir. Yes, sir. Yes, sir.
IE is equal to beta plus 1 times IB. If I replace this value over here, right? If I replace this value over here, I can write IB beta plus 1 times RE. This will still be equal to VE, right?
Yes, sir.
Now what does this mean over here? This means that if the base current is flowing in the emitter leg, the resistance which is being offered will be enhanced by beta plus 1 times RE.
Yes, sir. Yes, sir.
बात समझ में आ रही है?
Yes, sir.
Now what we are talking about here, that if IB is flowing in the emitter resistance, so the resistance will be enhanced by beta plus 1 times,
Yes, sir.
right? So this means what we can say, that if, as we know, beta plus 1 is approximately equal to beta, because beta is a big value, right? Are you with me?
Yes, sir.
So what we
Yes,
say,
sir.
that if beta times RE is greater than or equal to 10 times of R2, then we should be able to use the approximate method, right? If this is that much, this means that there is the base current which is flowing over here is very, very negligible. And if it is very, very negligible, then we can use the approximate method. Otherwise, we will be using the exact method. If this condition is valid, we will be using the approximate method. If this condition is not valid, we will be using the exact method. Are you with me?
Yes, sir.
Yes, sir.
बात समझ में आई है आपको?
Yes, sir.
If this condition
Yes,
is
sir.
valid, this means the base current which is flowing in the base of the circuit is very, very small as compared to I1 and I2, right? And if that is the case, then we can proceed with the approximate method. Okay, and what is the approximate method? Now let's see. So if this condition is valid, we start with the approximate method. And in the approximate method, what we say that the voltage at the base, VB, right? The voltage at the base, let me redraw it. We have R1, we have R2, and this is VB, which is connected to the base of the transistor, right? And over here we have VCC, which is being provided over here, and R2 is being grounded. So if we say IB is approximately equal to 0, and when it will be the case, it will be the case when this condition is valid. Beta times RE should be greater or equal to 10 times R2. If this condition is valid, we can go ahead with the approximate method. And the approximate method, we need to first find VB. So what VB is going to be equal to? VB should be equal to the drop across VR2. And what is the drop across VR2? Anybody?
I2 into R2.
I2 into R2, right? And I2 into R2 should be taken as I2 into
0.
R2. And as we have said, I1 is equal to I2, right? And if this is the case, so this means we have the current flowing over here is equal to the current flowing over here. I1 is equal to I2. So this means I1 and I2, they are the same current. So this means what is going to the value of VR2? Anybody? Or what is
I1 R2. I1 R2.
if you see over here? We have VCC, which is being connected to R1 and R2, right?
VCC into R2 divided by R1 plus R2.
Right. So using the voltage divider rule, we can simply write it like this, that it will be equal to VB is equal to VCC divided by R1 plus R2 into R2 over here. Are you with me? This is going to be
Yes, sir.
our base voltage, right? When this is going to be our base voltage, so we also know this thing that VBE is equal to VB minus VE, right?
Yes, sir.
Or we can say VB is equal to, or we can say, let's suppose we say VE is equal to VB minus VBE, right?
Yes, sir.
Are you with me? And similarly, I can also write IE is equal to VE divided by RE, right? Are you with me?
Yes, sir.
And similarly, I can say that as IE is approximately equal to IC, so I can say that if I write from the output side of this circuit, so the output side of this circuit is going to be more or less the same as we have. The output side is going to be from the same circuit. Okay, the output side is going to be the same. The equation, applying KVL to this, we obtain the same equation that VCE is equal to VCC minus IC into RC plus RE. But over here, the value of IC will be taken from IE, which we have just calculated, from here, right? That IE is equal to VE divided by RE, where VE is being calculated from VB minus VBE, right? Are you with me?
Yes, sir.
ठीक है जी. And therefore, what we can say, IE is equal to IC. Applying KVL to the output side, we get VCC is equal to IC RC plus RE plus VCE, or we can say VCE is equal to VCC minus IC RC plus RE. Are you with me? Right? And from there, we can actually find if IC is basically the Q value, so this will become ICQ, and if this is ICQ, this will become VCEQ, right? And that will be actually the Q points which we can plot it on the VI characteristic curve with the DC load line. Are you with me? Anybody having any question?
No, sir.
Is this thing fine?
No, sir.
Ji, question? जी प्लीज क्वेश्चन है तो करें.
नहीं है सर, आगे जाए.
सर
ठीक है.
वी इक्वल टू वी बी माइनस वी बी किस तरह है सर?
ओके, if you see VBE is equal to VB minus VE, right? ये पॉइंट क्लियर है आपको?
नो सर.
Okay, when we write two voltages with a voltage with two subscripts, so it is basically the voltage which is the difference between the two voltages. VBE indicates that this is the difference between the voltage at the base to the voltage at the emitter of the transistor, right? So VBE, when we write, so this means the difference between the base voltage and the emitter voltage is VBE, right? Are you with me now?
Okay, sir. Thank you.
ठीक है जी. So therefore from here, if we want to find the voltage at the emitter, it will be equal to VB minus VBE, right? And once it will be this, so from here we can find IE, which is equal to VE divided by RE, right? And from there we can say that as we know, the collector current is almost equal to the emitter current, and from there applying KVL to the output side, when we apply KVL to the output side, we get this equation. And if the IC value is at the Q point, so this means VCE value will also be at the Q point, so therefore it will be ICQ in the equation as well as VCEQ in the equation. And if you put the value of IC equal to 0, so we get the value of VCE, which will be at the cutoff, right? Because when the current IC is 0, so this means it will become the value of the VCE that will be at the cutoff, if you remember. So if I put, let's suppose if I say in the equation IC is equal to 0. IC is equal to 0, that indicates that we are at the cutoff point, right? And when we are at the cutoff point, this means if we put IC value equal to 0 in the above equation, this means VCE will be equal to VCC. And this VCE will be called as VC cutoff, right? And similarly, if I put the value of VCE equal to 0, if I put value of VCE equal to 0, if I put value of VCE equal to 0, this means I go into the saturation region, right? And when I go into the saturation region, so at that specific point, we putting the value of VC equal to 0 in the same equation above, which is this equation, right? If I put the value of VC equal to 0, I will have the value which is, if you see, if I put VC equal to 0, it will become VCC is equal to IC RC plus RE, right? And this means IC is equal to VCC divided by RC plus RE. And over here I will call IC as IC saturation, which is the maximum current which is flowing in this. And these two values, the VCE cutoff and IC saturation, they actually provide us the two endpoints of the DC load line, right? Question? Anyone having any question? Is this thing fine?
Yes, sir.
ठीक है जी. Okay, so with this we have some examples as the assignment. The assignment from the last time is also not submitted, so kindly concatenate or combine the assignment as one, so submit it this time. So that
सर जी
way,
मैंने सबमिट कर
सर
दिए.
सर वो तो हमने
सर
जिस
बहुत
दिन सबमिट किए है सर हमने
कर दिए?
अनसबमिट करें फिर. हाँ हाँ
यस
सर
सर.
कर दिया.
अच्छा चलें ठीक है, फिर ये जो है it will be the next assignment, right?
यस सर.
sir.
ऐसे
Yes.
असाइनमेंट नंबर 3.
हेलो सर.
क्योंकि कुछ
Hello.
लोगों ने नहीं किया था, तो मैंने कहा इस वजह से वो अगर चाहें तो कंबाइन भी कर सकते हैं. ठीक है जी.
हेलो सर.
ओके.
सर उसका अनाउंसमेंट रात को हुआ तो इसलिए हमने रात को सबमिट किए.
अच्छा
सर
ओके,
हमने भी सबमिट नहीं किया सर.
चलें ठीक है. मैं इसीलिए आप लोगों को वो दे रहा हूँ, लेवरेज दे रहा हूँ. If you want, you can combine it together, right? और
कंबाइन में सही हुई सर जी, कंबाइन में।
ठीक है सर, हम उसको सबमिट करेंगे, फिर क्यूआर में फिर वो करेंगे,
नहीं,
फिर
जिसने
ये भी
सबमिट
अटैच
करा दिए
करेंगे।
वो अनसबमिट ना कराए, जिसने सबमिट कर दिए
ठीक है
ठीक है।
सर,
हाँ जी ठीक है।
ठीक है सर।
यस सर।
सर इस असाइनमेंट के लिए फिर आप अलग से
हाँ जी,
नोटिफिकेशन
अलग
करें।
से इसके नोटिफिकेशन कर देते हैं, ठीक है, कोई
यस सर,
मसला
थैंक यू।
हेलो सर।
नहीं जी।
हेलो
क्वेश्चन
सर, हमारे ईमेल पे सर नोटिफिकेशन नहीं आ रहा सर।
ये तो यार फिर उसको कहें क्या नाम है, तो आप क्लासरूम देखा करें ना, गूगल क्लासरूम देखा करें।
सर गूगल क्लासरूम में सर नहीं
असाइनमेंट सेंड का क्या नहीं खराब ये
ओके
भी
जी,
असाइनमेंट सेंड करेगा कह रहे।
ओके जी। सो नाउ इट इज example which is given in the book is example example 4.8, example 4.9, example 4.10, example 4.11. Okay, let me write it for you. Example 4.8, 4.9, 4.10, and 4.11. Right? Okay. So these are the examples from now.
सर هغه assignment کې چې کوم ډیټ دی هغه زر د سبمیشن، نو ځکه دا کمباین کول سره نه پکار دا، بلکې فار ایگزامپل نیکسټ ټیوزډے ته سبمیټ کوو نو
Khazaba sahi show.
ठीक है, टेंशन क्यों लेते हैं सर, कर देगा।
ठीक है जी। ما وتاسو له لیوریج ورکول چې تاسو چې چا نه دي جمع کړی هغه جمع کړي. ٹھیک شو.
ठीक है सर, हम जमा करेंगे। थैंक यू।
Okay. So the next topic is collector feedback configuration circuit.
सर काफी नहीं है?
ये सर काफी है।
सर काफी है, आज मौसम भी कुछ ऐसे।
जी काफी है।
Actually, if you know the calendar for after the midterm is already being out, and we after this week we have only 4 weeks which are left.
सर
Right?
कम पढ़ेंगे, कम एग्जाम में दे कोई ना।
कम
सजेशन टाइम है
जी
सर 2 वीक तो प्रिपरेशन के लिए भी होते थे ना, इससे पहले 15 दिन
तो
वो भी
अब
कट गए।
वो भी नहीं है अब। ठीक है जी। सो टाइम टेबल आउट हो चुका है, तो इस वजह से
गुजारा कर रहे हैं सर जी।
मैं तो और कितना गुजारा करूं, मैं तो गुजारा ही गुजारा कर रहा हूँ।
सर प्रिपरेशन वीक भी नहीं है सर, जितना कम है उतना ठीक है।
चलो ये एक टॉपिक कर लेते हैं, उसके बाद फिर ऑफ कर लेंगे। ओके, वी विल हैव a session that is going to be restarted after 10 minutes. ठीक है जी, 10 minutes के बाद जो है we will start the next topic.
Excuse me sir.
जी जी
सर जमुंगा पेपर मसला वो पार्ट 1 नवशे
जी आगा मैं रोल अमीन साहब तवील है आप बताओ सर कोऑर्डिनेट पर
बस सही सर
सही है नोर से मसला को नहीं
न सर पार्ट 2 सही सबमिट शो पार्ट 1 की भी मिसिंग है सर।
हां जबरदस्त सही है। वी विल रीस्टार्ट इन 10 minutes. ठीक है जी,
ठीक है सर जी।
ओके।